So in general, I was lenient in grading, but unfortunately, the class average is not high, by the way. We have another student. Hello, how are you? Hello, Muhammad Al Khatabi. Hello, Uze. Hello, Kevin. Okay, everyone. This is the problem, and after this, we will start our next topic. The question says that you have to find the velocity when x is equal to 4 inches. This is some sort of table. So you can say there is a hole through this table, and this little wire passes through it and is connected to the mass. So the question says, find the velocity when x is equal to 4 inches. So I think one essential piece of information that I did not give you is that both of these fellows are starting from stationary. So initially, it should be written in the question, the masses are stationary. So why don't you do this question, everyone, and tell me the answer? How many agree? Initially, the masses are stationary. So again, you can do this question by multiple methods, but I think work energy makes more sense. So I will write the equation U1 to 2. Now, if this mass is stationary and this is stationary, the moment, let's say I had my hand here, I was holding this up. The moment I removed my hand, this mass wants to come down. This mass wants to go towards right. And when x equal to 4 inches, we want to see what will be the velocity of this fellow or this fellow, because there is just one string that connects them. So velocity of A will be equal to velocity of B. So you can say that U12, and there will be an O here for outside, is equal to delta T, and then there will be plus delta V G plus delta VE, correct? Now, I did tell you that the left part constitutes non-conservative force or external force. I don't think I did tell you anything about the friction, right? And what about external force? So you have to be a little careful. I'm not talking about any external force here. In fact, I will go as far as to tell you that if there is a simple pendulum with a massless rigid rod, this is a bob. When I take it towards the right hand side and when I leave it, what is my external force to the bob? Essentially, it is nothing. The fact that the bob wants to go 10, 10, 10, 10 is because of the initial condition that I used my hand to put it at 30 degree or 20 degree and I leave it. But if you are confused that, you know what, the bob is going like 10, 10, 10, 10, 10, 10, 10, throughout its motion, externally somebody is applying force, absolutely not. The fact that there is an mg sine theta component to the bob, that's why the bob goes like 10, 10, 10. So I think right now we are just completely diverting from the discussion. All I'm saying is that for this fellow, there is no external applied force and no non-conservative force like friction. So how many students agree that I will have to put a 0 here? How many agree? How many disagree? Outside, 0. Now you want to put a 1 here and a 2 here, so you do not get confused. I will put a yellow marker. So this fellow is sitting at 1 and this fellow is my 2. And the distance between 1 and 2 is how much? 4 inches. So let's finish the problem. The first piece of the puzzle is delta T. It will be equal to, so why don't you all help me with that? In fact, do it quickly. Do it and tell me the answers. In parallel, I will be doing. So focus on the part 1. We are not talking about part 2 right now. Part 2 is separate, okay? So part A is delta TA plus delta TB. 1 over 2 MA into V2A square minus V1A square. Students who don't like this and want to put A here and 2 and 1 here, they are allowed to do it. I usually like this more. Plus 1 over 2 MB V2B square minus V1. Now you have to be a little careful. Why did I write 2 minus 1? Huh? Why didn't I write 1 minus 2? Because you have to have a feel of the problem. When I am dropping the mass, at the end of the day, there will be a change in the kinetic energy. That will be the final velocity square minus the initial velocity square. So now there is one more thing that I want to tackle, because all of you are doing the British system for the first time, I think. You have to be careful in our Hibbeler textbook, at least. Whenever the author says 4 pound, 8 pound for an object, actually the author is referring to 4 pound force and 8 pound force. So you have to calculate mass. Now I do understand your confusion that how on earth we would know that is this mass or is this force. So probably in an exam setting, if I have to give you a problem, hypothetically, let's say in a British system, I will put LBM or LBF. Okay, so I will not confuse you in an exam setting. Our online students have any comments or remarks? Okay, everyone. 4 divided by 32.2 into how many agree? How many disagree? V2A square minus 0 plus 1 over 2, 8 over 32.2 into V2B square minus 0 square, 0 square. So delta T comes out to be equal to now. What about V2A and V2B? How are they related to each other? Let's see if anyone can answer. V2A and V2B, how are they related to each other? Uze, Kevin, Ugu. Yeah, so again, there is a square, right? So our life is super easy. V2A and V2B are equal, but as one of the students rightly pointed out, V2A equal to negative of V2B, because one goes there, other goes down, because I think you understand my point. But my point is that magnitude of both of them are equal. So, and in any case, there is a square sitting on top. So life is super good. Okay. Something happened with the internet. All of you can hear me, right? Now, 1 over 2 V2A equal to V2B. So can you please use a calculator and tell me the value of delta T? Since no online student is saying anything, I will test the speaker. Hello. Okay, correct. Now I will also increase the sound. Okay. So the students who have just joined us, please remember that the problem is fairly easy. I was holding the mass B by hand like this, and I removed my hands. So the mass B started falling down and the mass A started moving towards right. Both of these fellows were having an initial velocity 0. The question says, what will be the velocity of mass A or mass B when you have a displacement of 4 inches towards right? Hocham, can you hear me? No. I have increased the volume, but I should have, you can say something right now. No, Kevin, I cannot hear you. Can you hear me? You can hear me, right? Okay. Muhammad Al Khatabi, Uze, Haman, anyone who can. Okay, Haman is, I think, sitting here, right?
Hojam, we can hear you, but we can't hear Kevin.
You can hear me, but you cannot hear Kevin. Yes,
Yes.
yes, Kevin, we cannot hear you. Okay. I will suggest that you go towards the Zoom setting, go here to the mic and test speaker and microphone, and you can adjust the settings. So delta T comes out to be, no, Kevin, even right now I cannot hear you. 0.186 V2 square foot pound. Do we have any online student who also got the same fellow? No? You did not get 0.186? What did you get? Really? You, and what about Ogu? 0.186 you 0.186, na? Okay. 0.186, okay. Now V2A is equal to V2B, therefore I remove the A and B, okay? Okay, done. Question is over. Now all you have to do is do the last bit, that is delta VG. So for the mass A, how many students agree that there is no change in the height? So I will write MAG delta H. How many students agree? And plus, now this is the part where many of you get confused, because I still remember few students asked me this question, whether the value of G will be positive or negative. So my suggestion is that you just follow one clear approach. Don't get confused with the value of G. Just have an overall feel of the problem. So for example, for the mass A, it's a game over, gone. There is no delta H, right? But when it comes to mass B, the mass was sitting here, the mass came down. So there is a decrease in the potential energy. So you don't play with the value of G, you play with the value of delta H, right? So it's pretty much a game over. Another thing is the V is capital. Small v curly is velocity, capital V straight is potential energy change, delta Vg I mean. So MV is 8 divided by 32.2. Multiply by G is, oh, 32, no, 32.2. It's English system. 32.2. Multiply by delta H. Delta H, one of the students said, is -4. He is right, because if this fellow goes 4 inches, this fellow goes below 4 inches because of one rope. I am sorry, because of the fact that there is just this fellow goes like this. It's not like there are two strings here. So you said 4 inches, so I will put a -4. Now I will definitely divide it with a 12, I suppose, because otherwise your question will become very confusing, because you are throughout this problem talking about in um, feet, right? Oh, no, yes, at least delta T. Not exactly, because I think in delta T, okay, Kevin has again joined. Anyways, I wrote here foot pound. Yes, Kevin. Can I hope you can hear me, and now you can say something. Yeah, your mic is mute. Oh, I cannot hear you, Kevin. Now I divided this with 12, so delta Vg comes out to be, how many agree? Negative. Give me a value, please. 2 point.
66.
Yes, I can hear Jose. Okay, this was Jose. 2.66 pound feet. Okay, done. So I know that you are getting confused that how did you write a foot pound here? Because I was planning to use foot pound everywhere. So that's why I just quickly wrote a foot pound here, okay? Now, last part is finding delta VE. I will actually remove this. Oh, chat message. We have a couple of chat. Hocham, I restarted. Seems my mic is bad. So you just send me text messages now if you cannot use a mic. So at least I can answer your questions. So don't worry. Razor is there. Let me remove it. And delta VE equal to, now I will say 1 over 2 K delta 2 square minus delta 1 square. How many agree and how many disagree? Now I will write 1 over 2. The value of K is given to me. How many agree? That is 72 pound per feet. And I will actually squeeze everything here. Now delta 2 is, how many students agree? Okay, delta 2, follow me. Delta 2, okay, forget about delta 2. Let's focus on delta 1. I think delta 1 is easy. The unstretched length is 12 inches. Stretched length is 18 inches. 2 dash means inches, okay? 18 minus 12 is 6 inches. Are you following me? Boom, it's a game over. Now let's play with the first part. Huh? How many agree? Now, for the first part, delta 2, when this fellow stretches, so I will use a marker like this. Are you getting my point? So the mass arrives here. So you can see that this fellow is 4 inches. This fellow is 18 inches. Huh? 18 minus 12. Did I say 18 minus 6? Oh, apparently I have made a mistake. I said 18 minus 6. Why did I do that? 18 minus 12. Sorry. Thank you. Oh, your question is, shouldn't we divide it by 12? Okay, we will divide it. Yes, you are right. Okay, I agree with both of you. So let me go step by step. 18 minus 12. And one of the students said, why aren't we dividing it? Very good. 18 minus 12. So I will agree with you and I will divide it with a 12 square, okay? And delta 2, follow me, 4 square plus 18 square. You have to give me, yeah, 4 square plus 18 square. So I will write a 4 square plus 18 square. This will give me, okay, this is getting confusing. So let me go step by step. Let's say 18 square plus 14 plus 4 square gives me the square root, gives me 18.43. Now 18.43 is equal to L2 minus what is L naught? That is 12. It gives me 6.43. Now 6.43 over 12. 6.43 over 12. You have to give me a value now. 0.53. 0.537 is in my notes. And should I put a square? I should, I think, right? Now, do not get confused. Why didn't I put a 12 here? Because I have one of the students already divided 6.43 with a 12. Now, so I will write this fellow is already in feet square. Now this whole chunk also is in feet square. So can you please give me the value of, this looks so confusing, right? You can give me a value of delta VE, okay, everyone. I hope we get a right value. There is a high chance we have made a mistake. It's just so, squeezed everywhere. Huh? No, it's not 10.13. So 1.36? Yeah, finally. It's a sigh of relief because I was afraid that we have made it complicated. Foot pound. By the way, 6.43 over 12 was 0.537, right? So if everyone wants, I can put a 6.43 over 12 square here, okay? Everyone agree?
Can you explain the units from that part again?
Yeah, I will. In fact, I will first change this because this is the source of confusion, I think. And then I will answer your question. 6.43 over 12. Then I will put a square, right? Okay. Yes, I will answer your question. So look, the whole point is that when this mass is sitting here, it appears to you that it is not stretched, which is wrong. When this mass is sitting here, although it seems to you that, the spring is straight, so easy. No. The unstretched length was 12 inches. So yes, L naught is 12 inches, the unstretched length. So when I put the spring on a table, 12 inches. But when I connect it with the mass A, it gets elongated to 18 inches. When it has already elongated, it will itself have a potential energy, which is 1 over 2 K delta 1 square. So in order to, so don't get confused that this L naught is this orange line. This L naught is the unstretched length. So 18 inches minus 12 inches gives you how much it is stretched initially. Then how many agree? Okay, I forgot. Where was I? Yes. Then when this mass goes towards right, how many agree that there will be a 4 inches displacement here? So the height is still 18 inches. So the hypotenuse will be 18 square plus 4 square root. So one of the students said that the answer comes out to be 18.43 inches. So the unstretched length is 12 inches. So I subtracted by 12. So I got a stretched length of 6.43 in the final position. I took that 6.43 chunk here. I divided with the 12 to put it into feet. I took a square to get delta 2 square. And boom, question is solved. It makes sense right now. Who's it, right? Everything is fine now?
Yes, yes.
Good. Very nice. Okay, everyone. Then delta VE you got. So 6, 5, 4, 3, 2, 1. I'm stopping here for 30 seconds. Please make final adjustments. Note down your numbers. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So last but not least, do the number crunching. My final equation becomes 0. Go back. 0 equal to delta T. Delta T you told me as 0.186. V2A is equal to V2B. Then we came to the conclusion that delta VE comes out to be, delta VG come out to be negative 2.66 pound feet. Negative 2.66 pound feet. Then the last chunk comes out to be delta VE as 1.36 foot pound with a positive sign. How many agree and how many disagree? Now there are many students who are saying, how did for kinetic energy you use foot pound? That's what I'm trying to tell you. The rest of the terms are in foot pound, right? So this fellow will be in foot pound. So V2 comes out to be, give me the value. For V2? 2 point? Yeah, something north of 2.5. Yes, 2.64 feet per second. Boom. We get nice and beautiful answer. So mass A is going in this direction, mass B is going in this direction. When the displacement is 4 inches, this is what we get. Now, I am going to give you 5 minutes. So at 2:11, you should be able to do the next part. The next part is, so please follow me. I remove my hands from below mass B. The mass B falls downward. Mass A goes towards right. At a certain X, the mass A will stop right, and so will mass B, because VA equal to VB, because there is just one string, not two, not three. So this means if I ask you find the X max, this means I'm talking about the fact that V2A equal to 0, V2B equal to 0. So life can't be better for us. All we have to do is just tackle this. You can do it yourself. I will not solve it, by the way, but I will wait for 5 minutes for everyone to at least try this, okay? So this chunk goes to 0 equal to delta T plus delta VG plus delta VE. So this fellow will be a function of X max. This chunk will be a function of X max. No, what happened? How many agree? What about delta T? Why don't you help me with delta T? So for both the masses, delta T will be 0, right? Starts from 0, goes to 0, both the chunks. Delta TA, 0, delta TB, 0, 0, 0. So all the students have agreed. And X max value I will give you in feet after 5 minutes, but I am not going to solve it. It's your home assignment. We will start at 2:13 now. Our online students can tell me the answer. Gail, Kevin, Muhammad Al Khatabi, Uze, Haman, Ugu. Yeah, oh, your answer is not exactly 0.618. Well, there might be some mistake. But I'm not sure why. You should get 0.618. By the way, it's very dark for our in-class students. Let me switch on. I hope I don't end up switching off everything. Oh, it's better, right? Okay. Okay, we can stop till 2:15 and then I definitely will start the next topic. Okay, everyone, I think this is the right time I have to proceed. Anyone got 0.618? No? And that's fine. It's your home assignment, figure it out. So our topic is, I will try to post some ungraded homework or graded file. So our next topic very quickly is solving dynamics, that is kinetics. I think we already have been doing this. You do understand. We have been doing this for a while. So I don't think that I need to go over this again. We have talked about it. What I will do talk about is something very quickly. Let's say I have an object going like this. You will understand the next topic very easily. And please, those ungraded files that I have been sending you, please understand that's a practice problem file. So it's not like if I give you graded file only then you will practice problems. You have to be practicing the problems. So let's say this is the path. And let's suppose this is a particle. Now you do understand that we are talking about particle in this class, right? The rigid body kinematics was, of course, you already know it. But after that, when it comes to kinetics, we have only been talking about particle kinetics. So this is again a particle. Life is super good. I will just put a tangent here. Now, if I put, oh, this is confusing. So if I put a tangent here and if I ask you, this is mass, this is velocity, this is this, then this is the position vector r naught of this particle. Then let us talk about first the statics part that we studied in our statics course. We, from our statics, understand, okay, for statics, I think, of course, summation of moments would be 0. So I think let's not write a statics here. We are talking about dynamics. So I will say d over dt You have to give me 1 second. D over dt. Give me 1 second, please. Yeah, d over dt of R naught cross mv will give me R naught dot cross mv plus. So what is the second part of the derivative? It will be R naught multiplied by mv dot. Now I do understand that R dot is nothing more than V, right? So V cross mv plus R naught, which is a position vector, cross mv dot. So why don't you all help me a little bit? What is the meaning of this chunk? What will be the answer? 0, right? It's a cross product. Mass is a constant. So for cross product, same quantity will give me a 0. So I get a very beautiful answer of d over dt of R naught cross mv equal to R naught cross mv dot. Now many students are saying, what on earth is happening? You suddenly started taking a derivative of this quantity called R naught cross mv. Now, if you think about it, mass multiplied by velocity is momentum, and essentially what you're doing is you are finding the momentum mv multiplied by r. So this is what you are trying to find, and I will say that summation of moments about this point is equal to d over dt R naught cross m v dot. Now I need to explain something. So I removed the dot and I put a d over dt. Now there are many students who are saying, what do you mean by that? What I mean is that for statics, for example, this object is stationary, it is stationary. If it is stationary, then we do understand that there is no, so let me put this way, this object is not going in a linear fashion. This object is also not rotating. Hence, it is in static equilibrium, right? So if I just tell you that this is not moving in a linear fashion, but it is rotating, then you will definitely tell me it is not static equilibrium. My point is that if this object is rotating, is moving about this point, then we definitely know that the summation of moments is not 0. It's non-zero. And what is the non-zero quantity? That is the chunk sitting on the right hand side. As simple as it is. And if you're getting confused about this dot, you don't need to worry. You can see that I removed the dot and I put a DOD. Now, in order to reduce this confusion, I will write angular momentum as H naught equal to R naught cross mv. So this, from here onwards, if I ever ask you, tell me angular momentum, R cross mv. What is R? It's a position vector. Now don't use the word radius, use the word position vector. So should I summarize everything in a neat and clean fashion so you don't get confused? I think I can wait for 1 minute here. You write everything, then I will summarize everything. Or probably I can squeeze here. Summation of moment is equal to d over dt of h naught. I will put a beautiful h naught vector with a dot. Then I will also write summation of f naught equal to this. You will answer. What will come on the right hand side? Think about it for 2 minutes. Summation m naught I wrote. Oh, sorry, I made a mistake. There is no naught here. because I'm taking the summation of moment about point O, but summation of forces is summation of forces, right? And when there is a vector, what does that mean? It means vector means it will have an x component, it will have a y component, it will have a z component, and if you dislike the vector, the summation of forces vector is summation of forces in the x direction, summation of forces in the y direction, summation of forces in the z direction. So why don't you fill in the blank for me? If this right hand side has mv multiplied by r naught, that is the position vector, what will be the, I'm sorry, if this right hand side has d over dt r naught multiplied by mv, what will be the right hand side of this one? Chat message. Pocham, please, what is m naught? We have another chat message. Give me 1 second. Like, what is it called? Summation of moments about point O. I will have to write it here. Summation of moments about some point O, about which the object is rotating. So any student? It will be, I will tell you, d over dt, because there is a d over dt, this, so d over dt now, d over dt, mv, no? So if I do take a d over dt of v, that is acceleration. Summation of forces is equal to mass multiplied by acceleration. Summation of forces is equal to the rate of change of linear momentum. No, it does not ring any bells. Summation of forces is equal to rate of change of linear momentum, or you can always think it like this. Summation of forces is equal to ma. What is a? dv by dt. Pull out the d over dt before, so it becomes the rate of change of linear momentum. Now what you have to understand is that whenever you get confused about this, think like this. If I have a, not if I have a, but usually what happens is that when the police have these rubber bullets, the whole point of a rubber bullet is that when they shoot a rubber bullet, the rubber bullet recoils, right? It hits and it recoils, right? Are you getting my point? So when the rubber bullet recoils, the momentum has to be conserved. So the person who is exposed to hitting of that rubber bullet has to fall backwards. And the moment a person realizes he is already or she is already, fallen backwards. So that's how police operate. But anyways, probably not the nicest of examples, but anyways. So, okay. So what I can do is, just to put everything in perspective, I will remove the d over dt. I will put a g. Did we use a g here in this class before? I think we did. We did, right? So now you will put a beautiful bracket here, and you will say time rate of change of momenta. Time rate of change of momenta. Momenta, M-O-M-E-N-T-A. So let's say I have an object. Let's say it is going towards right, and the object is also rotating about its axis. So the moment I ask you, tell me about the dynamics of this object that is rotating. So you can think about it like this. I have a disk. I twist it and I throw it towards the right. So it is rotating and it is going towards the right. So you will say there is a summation of forces in the x direction, done. There's a summation of moment equal to I alpha that is happening for that object. So there will be two chunks of the dynamics problem. If you are planning to approach the problem using the summation of forces is equal to rate of change of momentum, you will also have two of these fellows. One will be telling us how much it is going linearly. The other will be talking about its rotational component. Oh, okay. I hope it is making I hope it is making sense. Now I will write that these two chunks. So unless we do a problem, it will not be clear. Let me solve some problems completely. define the dynamics of a particle, defines the dynamics of a particle in space. So you don't say this, well, these are the only two equations that define. No, summation of forces you do or summation of moments you do, it also defines the motion completely. Okay, everyone. That brings us to the last piece of the puzzle before we solve our first problem of the day. That if I have momentum, so now you fill in the blank. So this is not linear momentum, this is rotational momentum. So there would be M and a V and an R, right? So there would be R, there would be M, there would be V. So you have to be very careful that there is a cross product. Oh, sorry, what did I do? This is not vector. So this is a cross product, okay? In an exam setting, don't write MVR, please. What is R node? It's a position vector starting from O to the point of interest, to the object of interest, to the, now, it does not hurt to put it like this, because in our classes, you know, I have been doing like that. I, J and K, right? You do remember. This is usually how I do. I cross J is K, K cross I is J, K cross J is negative I cross K is negative J. But I have even seen in our exam papers, many students are comfortable like this. So I thought I should do it. IJK, you write it first. Then you write RX, RY, RZ, because the position vector will have three components, right? Of course. So for example, if there is a point object right at that corner of the room and there is an elastic band, so it keeps on getting stretched, the person arrives at that top corner. If I ask you what is the position vector of that person with respect to this origin, for sure it will be this X, this Y, X and Y, X, Y, Z. This is X, that is Y, that is Z. So we will just measure this, and this, and that will be the position of that person that would be sitting on that corner on the rooftop. So I will have RX, RY, RZ. I will have MVX, MVY. How many agree and how many disagree? MVZ. Now, you have to be clear on one thing. Just imagine if I'm talking about, let's say I have, let's say 2 markers, which I apparently can't find. Anyways, so let's say I have, yeah, so I have this 2 fellows are joined and I flip them like this. So they are rotating in this 2D plane, right? Because that's a 2D plane, right? So if it's a 2D planar motion, students will all tell me, why don't you, for 2D problems, why don't you make it a little easy for us? So I will make this easy for all of us. So I will just remove 2 pieces. There won't be any RZ. There won't be any MVZ. So these 2 chunks will go away. And your H naught will come out to be RX. You don't need to get confused. By the way, we will do a problem. It will be more clear. Minus RY MVX with a K unit vector. And there are many students who are saying, how did you suddenly write this? And I will try to explain it like this. Let's say I have 2D plane like this. I have RY. I have position vector RX. This is easy, right? Now I'm not going in the Z direction. Let's say this is the whiteboard. Everything is happening in this 2D part. So This is the point object, nice and easy, sitting casually. Now, this object is going in this direction with a Vy. This object is also going in this path with a Vx, right? And let's say there is this elastic band, which I use the word position vector, right? So the good part about this elastic band is it keeps on stretch. So it's hypothetical. It's not a physical elastic band. It's a position vector. But I think it like this, that assume that this is some sort of a string. Wherever the person is going, the string is just following him or her. This is my position vector. I call it as R node. The position vector is pointed like this. Now, you do understand that if it has two components, Vy and Vx, they are not equal in general. So you will have, let's say, the resultant vector sitting like this. Okay, it's just a horrible drawing that I have made. Give me 1 second. Let me be a little more organized. So I think, yeah, this is now correct. Vx is like this. And my yellow line for this one is here. So in general, I'm not suggesting that this is 90 degree. This angle can be different. And this is my MV. You know, I was trying so hard that this angle does not appear to be exactly 90 all the time, but unfortunately, it appears to be again 90. Anyways, this is some general motion. So this is my Rx. This is my Ry. Ry, Rx. So the S naught will be given as Rx My minus Ry Mvx K. Now, students who are getting confused, why K unit vector? Because if this is happening in this plane, then you curl the fingers of the right hand, your angular momentum should be in the K direction. And for students who are getting worried why there is a negative sign here, you have to understand that the velocity is towards the left. Anyways, it seems confusing, but my point is that I am making this just to explain to you that when I make this cross product, why I come up with a negative sign, because the object has a negative component of velocity. So although the angular momentum is in K direction, that's why you get this negative sign. So Rx Mvi minus Ry Mvx. Great, done. So that brings us to our first example. Before I do that, I will summarize that summation of moment about any point O is d over dt, rate of change of angular momentum. Please do not forget that. Then I will also go as far as to suggest that if you take an integral from t1 to t2 of this fellow with time, you get d of h naught, which is equal to delta h naught. So you say that area under the, do you remember impulse was equal to F into T, and it was equal to the change of linear momentum, right? mv2 minus mv1. This fellow is the, pretty much looks similar. Now you have integral of m naught dt, and you have this chunk sitting on the right hand side. So area under m naught t graph, which is equal to delta h naught. This fellow is a vector. Sorry, this is a vector. You have to be a little careful. And students who are saying that we don't remember the previous formula, what do you mean by that? I will say, please remember that everything is analogous. Analogy. So analogous is an English word with adjective, right? Analogous. Okay. I'm drawing analogy, I mean. Summation of forces dt equal to delta g. This is your impulse momentum relation. This relation is for moments. Done. So we can start doing our first example. Yes, so let's have a 6 minutes break. It's 2:37. We will start at 2:43. Yeah, the 60 minutes classes are, I think, are very helpful, you know. No, I mean the 50-minute classes are very helpful, and the two classes together are probably a little long.
And they just changed it for the program. They said that like you have to be in a class only for 40 minutes because of the air and something.
I have
Just
no,
not-
I will not comment on that, but yeah.
No, I mean, for example, I have a face-to-face class and then I have an online class. I mean, I need to take the online class in here to work. What's the difference here? I need to be here. With the laptop.
We just have to follow the rules, I guess, so that's fine.
Rules are made to be broken.
Okay. Yes.
When I was on the internet, I was looking for your office hours.
Uh,
And then I saw your publication about
uh,
the military energy thing.
energy harvesting.
Did you do that? Actually,
Energy harvesting? The publications? Where did you see my profile?
again, I think it was the University of Arabic.
You mean American University of Iraq?
Yeah.
Yes, yes, my publications are written there. Yes, so in graduate studies, that's what you do, right? So, yeah, but you will have an advisor, you will have a mentor, and he or she will definitely guide you. So, it's definitely doable. There will be a topic, they will tell you, and it does seem impossible. Even when I started off, it seemed impossible. But when you have somebody to guide you, do this, do this, do this, and it is very many times it's very concise set of instructions. So nothing to worry, you will end up producing a publication. All of you, no, all of you can 100% do it. It's exactly like somebody who is not pursuing engineering and he sees you or she sees you and he and she will be like, how are you doing engineering? And you would be like, no, there is a particular set of instructions and it's doable. So
I saw also, I didn't saw, don't worry, I just, when I was looking for your officer, I just saw it.
yeah, that's fine. But my point is that it's very doable, and I definitely encourage all of you to definitely fill out applications for a graduate program, and you will definitely be getting some teaching assistantship and research assistantship in some good university, and you will be doing some research work, and you will be getting paid for it. So you will be able to pull off your graduate studies, master's leading to PhD in no time. So definitely it's doable. And in this precarious job market where, we have COVID-19 and so much unpredictable stuff happening, never hurts to fill out an application. You never know. So it's doable. Okay. Where are we right now? Great. So I think we are back. Now, there is just one remark I want to give you, and that remark is that just remember one thing. If you understand this, then it's a game over. If you do not understand, then it will be very hard for you to understand. Look, when you have an object that is going in a path and you want to find its angular momentum, you have to be a little careful. If you put it in the magnitude form, then this is wrong, by the way. You can see I have made a mistake. You have to put these two little bars that gives you the absolute value or the magnitude. We know from our cross product, it will be RMV sine theta, right? Sine phi. Let's call it psi or phi. Now this angle will be between this position vector and the velocity vector, right? But what will be the angle? So make this diagram. The object is quietly going in the vertical direction. The position vector is this one, right? So the position vector, the fellow keeps on going upward. The position vector also is attached to it. All you have to do is extend the position vector. Light green color and dark green color are different here, okay? You extend this arrow, the angle that the velocity vector makes with the position vector extension. This angle is psi, phi, whatever you want to call it. I'm not even sure. Is it a psi or a phi, by the way? I'm actually asking now. Yeah, right. This is psi, I guess. Okay. Yeah, call it psi. Now that you understand this, boom, it's a game over. So now all you have to do is solve this problem. The question says that you have some sort of a package. That package has this value R. The angle that this package is making from this vertical line is theta. Now you have to be careful. The angle is given to me like this. If it had been given at from here to here, okay, then I would have to tackle that problem. But it's the same thing, like not same thing, but theta right now is given to me like this. The question says that the position, I'm sorry, the question says that the velocity is like this, tangent, right? It's understandable that it will be tangent. By the way, what will be the angle? The angle appears to be as 90. It's pretty obvious that for this problem, I have a 90-degree angle. Now,
Hojam,
yes,
Hojam, for the first one,
yes.
the one you said you make the line between the, yes. So that angle phi, is it it's also equivalent to I over j, right? Like the angle between them. Like it.
Is it? No, 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 no. No. So, for example, you are saying this angle psi is 90 or not, or are you talking about this side?
The first example.
Yeah. So,
Like let's say that we are using the first method,
so for example,
and
if
we're giving R in terms of I and J and V in terms of J. So if you solve and you get your output to be in terms of I and J, the angles between them is what's if? You take tan theta, tan inverse of 1 minute.
Got it.
Like,
got it. Yes, I think I understand where are you going with this. What you're saying is that what if we make a projection? You know, what we can do is we can probably, I understand your remark. Your problem is that your question is that can we write phi in the form of the components of V and R naught? I think this is your question. Yeah. The answer is yes, I believe so. But right now, from the top of my head, I'm not sure. But you are right. Probably I can tackle this part later, probably in the next class, because you are right. Psi can definitely be found. I think so, yes. But right now, from the top of my head, I'm not sure. We will have to make projection. You're right. I agree with you. But right now, my point is, if this is the angle, then we can quickly approach this problem. Okay, everyone, on that remark, let's tackle this. So the free body diagram will have this fellow as mg, and I can just make two components. This is, and then I will have another component here, and I will have another component in this direction. So finally, I get summation of moments, but it was a very good question, by the way. You are 100% right. Summation of moments is equal to R cross mv dot equal to, what was the equation? H naught dot, right? Everyone agrees with this part. Now you proceed. So now you will have H naught dot equal to, now follow me. What you will say? You will say R mv sine of angle between them. So it will be sine of angle. Now be a little careful. Make an extension of R, get the angle between, what was that? Get the angle, we had to find the angle between the velocity and this extension. So here it will be R, give me 1 second, H naught equal to, I suppose, minus R M V dot K. And summation of moment, it comes out to be minus mg. Okay, chat message. R is constant. Why is it d over dt not 0? Where did I write chat message? d over dt of R is not 0. So let's go back. Where did I say that? So where did we take the d over dt of R? We are not taking d over dt of R, no? We are just talking about this fellow, the v dot, right? So for example, I think I did take a d over dt and I proved it to you, no? So let's go back and see the derivation. d over dt R cross mv equal to R dot cross mv plus R naught cross mv dot. So R dot becomes v cross mv cross product, v cross v, because this is magnitude or is just mass. So this will become 0. So that is the answer to your question. I already took the whole chunk as 0. So it will be R cross mv dot only. So now I will write minus mg sine of theta k. Now this angle is theta. Let's see if this makes sense or not. And finally, I will write that this summation of moments is equal to this chunk. So you can just equate it to this fellow that you created, minus R m v dot k. So I will have k cancels with the k. I will get a beautiful answer of v dot equal to mg sine theta over rm. Now, like seriously, if I had asked you, and by the way, I think r also cancels with r. There is some mistake that I did. Summation of moments is equal to r cross mv, r cross mv dot. So it is equal to summation of moments is, this is mg cosine theta, this is mg sine theta. So if I have to take the summation of moments about this point, which you call as your point O, then it will be mg sine theta multiplied by the distance r. So summation of moments should have minus mg sine theta multiplied by r. I have already made a mistake, but no one pointed out minus mg sine theta r, and there is a k unit vector. Now there are students who are getting confused because they are saying, what on earth is happening? My point is that I am trying to take a summation of moment about point O. So please follow me. Look, summation of moments about point O, mg sine theta is in this direction. Mg sine theta multiplied by r is giving me a very beautiful moment. The negative sign is because of clockwise moment, right? So mg sine theta multiplied by r, because mg sine theta is directed towards left, clockwise moment, minus mg sine theta multiplied by r. This is k unit vector. Why is k unit vector? Because we know that the summation of moments will have an answer in the k direction, right? Next part is, why am I equating it to minus r mv dot k? Again the same answer, because h rate of change of momentum, this is dot, this is about O, it is equal to minus r multiplied by mv dot. So you can write here that at equal to, should I explain again? At is equal to d by dt v. So I think you need to differentiate between this d over dt and the little o that is sitting for about origin. This is dot. Okay, the question said that we had to find the acceleration. I think I forgot to tell you what the question was. I wanted to ask, find the acceleration, AT, question mark. And we know that AT equal to V dot equal to question mark. Now, let us make a correction here. So if I equate both of them, R cancels with this R. So my final answer will have just G sine theta. Now, like honestly, there might be students who are saying, you have done this question with so complicated form. What was the tangential acceleration? You would have directly told me G sine theta, right? So please look at like this. If I have a bob, I take the bob here and I leave it. What is the component of force that brings the bob like this? That is mg sine theta is that force, right? That is bringing the bob like this. So it is pretty obvious that the tangential acceleration is g sine theta. The higher you take the bob, you leave it, it keeps on coming down, the more its velocity keeps on increasing. I'm sorry, I mean the more velocity increases because g sine theta, g sine theta, g sine theta keeps on adding up. And just quick remark, can any student tell me how did I write? This is a trick question, by the way. How did I write Rm V dot here and why isn't there any sign of angle? Because you can see here, I wrote here RMV sine phi, right? So if you look at the V dot, because this is what we said, the angle between the extension of the position vector with the velocity is psi. So if you keep on extending this, that will be the extension of R. And if you look at this, this is your V. So what is the angle between the extension of this R and this V? That angle is 90, right? So hence you don't see any sign of psi. Is this point clear? To our online students, is this confusing? Is it clear? Is it getting better? Yes, no? I do understand the point that you are still like, why didn't we do the summation of forces? It was so easy, right? Okay, no, yes. Okay, 6, 5, 4, 3, 2, 1. This problem is our last problem of the today's class. You will have to do it yourself, by the way. So the question is something like this. Any questions by Kevin, Oze, Umut, Ogu, Daniel, Haman, and you are Melissa, right? Melissa. So any questions by anyone? We have a chat message. No question? Okay. Okay, I will see whether the practice problem file has enough problems. Otherwise, I will make more problems for you. More problems and questions, I will make it for everyone. So this is a velocity of a car. This is 100 meter. And this is our radius of curvature. This chunk has a velocity of 5 meter. What is that? 5 meter per second, I suppose. The question says that right at this point, oh, what happened? Colors got disturbed. The person put foot on the accelerator. The moment he put the foot on the accelerator, wow, wow, we get F equal to 150 Newton per, okay, I'm not sure about the units. Yes, Newton per second square multiply by T square, I suppose. The question says that right at this moment when the person put foot on the accelerator, and at this point his or her velocity was 5 meters per second. Very nice question. Find V2 after 5 seconds. Okay, so the stopwatch is right now with us. We start the time. Now it is a 2D problem, right? Everyone gets that? If you, for example, create a 3-dimensional drawing, that will be rather complicated. This will be our 3-dimensional drawing. So you will have, so again, I will repeat the question. Right at this point, the person put the foot on the accelerator. The moment the person put the foot on the accelerator, the force is 150 Newton per second square multiplied by time square. So the time starts now. Now after 5 seconds, what will be the velocity? If at this point, the velocity is 5 meters per second, okay? So for this 3-dimensional drawing, I will create an arrow like this. So this is 3D drawing, okay? This is our car that is going very nice and smoothly. Let me draw a car. And the weight is acting like this. And how many agree that the normal force will be acting like this? And the force will be acting like this. Oh, this is just horrible drawing. That's what I said, it is hard. So let me try one more time. I'm trying to make a 2-dimensional car. Okay, we have a chat message. Do we know acceleration? No, we don't. But we know force, na? If we know force, then the whole thing is done. We know the force. Let me try it one more time. Probably you can help me a little bit. Oh, now I think I did a good job. Now the force is given as this is our force. Where is the friction, by the way? This is the friction. This is the weight. This is the friction. And I will change this arrow so you don't get confused. And the normal force is the green fellow, right? Now, why did I make this complicated drawing? Just to explain to you what is happening. Do you care about weight and normal force? I don't think so. Do you care about the friction? I don't think so, because friction is going through the center. If you talk about, look, follow me, weight and normal force, what they will create? They will create motion in this plane. The car is not definitely flying in the sky, right? So all I care about is the force F that will make it rotate in a circle. So think from the perspective of the fact that you are actually doing that summation of moment equal to the rate of change of angular momentum, right? Did I say it right? Summation of moments is equal to the rate of change of angular momentum, because that's how I'm intending to solve the problem. So I will say 2D problem means I need only, I think we can put V. V can only, no, we not can, we only need how many agree, how many disagree? Force. So now you can help me with the solution. I will just write the formula and you have time till 3:20, solve it. In the last 10 minutes, I will help you. Summation of moment about O. You make it this as point O. dt equal to the rate of change of angular momentum, this dot, equal to r cross mv dot. I'm intentionally making it a full circle because there is a little O here, so I don't want you to get confused. And you can write it one more time. Integral T1 to T2 R f dt equal to Rm delta V. No, I think there is a mistake. Sorry. If there is a T here, I think I made a mistake. The rate of change of, let's go back. Yes, summation of moments is equal to H naught dot. When I multiply with the time, why there is a dot? Yeah, sorry, mistake. Or probably you get my point, R cross MV. There is no need to write it now. And make sure you are not making any mistake here now. So what is T2, by the way? Anyone? So I write, what is T1? Why? Because I have the stopwatch, right? We have the stopwatch. So 5, and there is a 0 here, 0 to 5. So from the top, I'm looking. And when I'm looking from the top, I look at the friction that is responsible for keeping this fellow in circular path, let's say, along with the normal acceleration. I look at this V1. I also look at this chunk that is force because of petrol that is burning, because the person put foot on the accelerator. So from the top, I have a very beautiful feel of this. And when I look at in another dimension, I also have a look at beautiful weight and normal force. Do we have mass? Do we need mass? I think you are right. Yes, we have mass. Excellent question from one of our students. What is the mass? You are right. We need mass. Thank you. Mass is 1.5 megagram, and I honestly am not even sure why on earth a car's mass is given in megagrams. We are just happy that they didn't give us in milligrams, but just megagrams. So convert the megagrams to kilograms, okay? We have a chat message. That was quick, but Kevin, I have a different answer. I have an answer of 9.17. Why don't you double check? In fact, I can start doing it along with you. 100 into 150 Newton per second square integral. Wait a second, did I? Kevin, there is a t power 2 here. I hope you did not make this wrong. This is t power 2. Everyone, it's t power 2, okay? Okay, let's see chat message. Huh? This is t power 2. Look at here, t2. Sorry, t power 2. So when I do a t power 2 here, dt 0 to 5. Then there is a r that is 100 meter. Okay. Why didn't I write units, by the way? This is meter. This is meter. This is 1500. And then we have a beautiful delta V. What is delta V, by the way? It is V2 minus 5. Nice and easy. In meter per second. So the only mistake you can make is that you can overlook the fact that there is a t power 2. So t power 2 has an integration of t power 3 divided by 3. So now tell me the V2, by the way. V2 comes out to be 9.17 meter per second. You have to double check, by the way. Daniel got that answer. Did you get 9.17? Nice. Okay. Umut, Haman, Melissa, Ogu, Kevin, and Uze can also tell us. Oh, we also have Mohammed Al Khatabi. You can also tell us. We also have Gail with us. You got the answer 9.17? You did? Okay, done. Great. Kevin also made the correction, right? No confusion, right? Look, there's one more thing. Just imagine I just give you this question. No, this depends on your imagination, how you want to tackle the problem. In a setting where everyone is doing the problem with one method, seems obvious, okay, see the formula, but just imagine comes in the exam. Then you have to approach the problem how you find it feasible. I guess Newton's law would have helped you as well, right? So you can follow your own path. Should we do one more problem? 9.1666. Yeah. Okay. Let me make a countdown. 10, 9, 8, 7. But by the way, can one of you double check in that practice problem file that I gave you? I think I gave you 2-3 files. I'm not sure whether we have problems related to angular momentum. I mean, the kinetics using this principle. You can just double check, but I will give you. My point is, whatever ungraded files I gave you, it's not like, well, that's not a graded home. You have to practice, right? It's included in your exam, right? You will be judged in your midterm too. So please, even if I couldn't give you, right? First form, if I couldn't give you graded file, at least work with the practice problem file. Now you do know that solution manuals are actually available online, but I usually create a file for the students so they don't have to search for solution manual, although they are readily available. A beautiful problem, you can consider it as your take-home problem. Very nice, beautiful problem. This problem will give you a feel of why what we are studying is so helpful. The problem says that this chunk has a radius of 100 millimeter, and there are these four fellows that are very beautifully attached to it. Now these are massless rods. So let me use a single line. Then there is another massless rod, another one, another one. Now the question says, if this rod is 400 millimeter, how many degree? And this fellow is 3 kilogram, 3 kilogram, 3 kilogram, 3 kilogram, 3 kilogram, 400, 400, 400, 400. Then the question says that by looking from the front side, you have a view of this fellow, this fellow, this fellow, and this fellow. Someone is pulling it using some rope, let's say, with a force of 20 Newton. Now you have to be a little careful when somebody says they are pulling with a force of 20 Newton. What it means is that as long as the action continues, the force is 20 Newton. So for example, if someone says it's a constant force, right? So we have last 3-4 minutes. Just let me complete the problem. This θ1 dot is 0. You have to find that in order to take this to 150 radians per second, how long you should apply the force. What will be the force for all this time? It's a constant, 150. So, sorry, I mean 20. So 20 Newton, 20 Newton, 20 Newton. You just keep on applying this 20 Newton. Oh, I think students can also get confused. Will the direction of the 20 Newton will always be downwards? So yeah, so it's a rope, right? So it's 20 Newton, right? You keep on pulling it down, 20 Newton, 20, 20, 20, 20, 20, you keep on doing it. And this whole thing will go, it will keep on increasing its angular speed. Now, quick question, kinematics question to our class. Mohammed Al-Khatabi, Oze, Daniel, Haman, Melissa, Kevin. I hope I did not miss anyone's name. Umut, everyone. What about theta dot? Is it theta dot of this, or this? Whose theta dot are we? Which theta dot are we talking about all this time? What did you say? You mean this one? Okay. What about Umut? Which theta dot are we talking about? Is this theta dot different than this theta dot? Are you following me? This is omega. If the object is this one rigid object, then theta dot is theta dot. It's the same for, you remember that disk problem? There is a disk that is rotating and I am standing on that disk. If the disk is rotating at 2 radians per second, what about me? I am also rotating at 2 radians per second. So do not get confused. You have to be very careful. I have been emphasizing on this point over and over again. What about velocity? What about velocity at this center and what about velocity at this? For sure, the velocity will be different, right? Because it depends on the R of the R omega. But omega, well, that's the same for everything, right? For all these 5 fellows. Should we continue this problem next time, or do you want me to write the equation quickly? Let's have a voting. Should I write it quickly? Okay, I will. So integral T1 to T2 summation of m naught dt equal to, who has the stopwatch? We have the stopwatch. T2 20 Newton multiply by. So now I will put 100 millimeter. I think with respect to this distance, I think you were focusing on that which distance you will substitute. I understand, but my question was about theta dot. 100 millimeter dt, which is equal to 2 Newton meter delta t. And students who are getting confused, how did you come up with this? I will write the general expression for your own convenience. I use this summation of m naught, this is vector dt equal to delta h naught vector equal to h2 minus h1 vector about some point O. So I will put O outside. So I am using this formula, everyone. So now my answer comes out to be delta H is equal to H2 minus H1 is equal to 4Rm into V2 minus V2. And V1 is 0 because it starts from stationary position. So I get an answer of delta H. Let me use an entirely different color. 30.1 kilogram meter square per second square. And by the way, 150. Sorry. I think I made a mistake. This is 150. I apologize. This is 150 RPM. Sorry for that. And this is equal to 15.7 radians per second. Sorry, I gave a wrong value. So what will be the value of the V2? Can anyone tell me? What will be the value of this V2? This V2 will be equal to this 400 millimeter multiplied by this 15.7. And why did I write 4? Because there are 4 of these masses. So finally, delta T comes out to be, this is 2 Newton meter delta T. So your delta T comes out to be 15.1 seconds. Okay. Can I see the last question again? I keep getting 11.25. Okay, I think, okay, you can take a quick picture because I think now our students are also seeing that slide. Please take a quick picture. And I was saying this to Kevin because I think he wanted to. Okay. Okay. Yes. Thank you. Okay, done. I think I will just revise it. So integral T1 to T2 summation moment dt equal to delta H naught. That is the rate of change of. I'm sorry. It is equal to the change of the momentum of. Of course, we are talking about these 4 fellows. So delta H equal to H2 minus H1 equal to 4 times. Now there are 4 masses, so 4m. So mvr or r cross mv. So the force is being applied at like this. So that's why no angle appears. So we have 4 rm v2 minus v1. I put the delta H here, I get 30.1. So now I have delta H that I got, and integral summation of moment dt equal to this fellow. I want my left hand side. For my left hand side, I have 20 multiplied by 100 millimeter gives me the moment. Integral over the dt 0 to t2. So t2 minus 0 will give me delta t, and this chunk is 2 Newton meter delta t. So 2 Newton meter delta t is equal to, I suppose, the fellow on the right hand side, that is delta H. So can you double check? Are you getting 15.1? No? Yes? So all you have to do is delta t is equal to 30.1 divided by 2, right? So you will get something around 15.1. Okay, everyone. Just before you go, just one quick remark. Did I tell you the mass of this big fellow? This fellow? Did I or did I not? Because I think one question everyone can ask is, why doesn't this mass appear? So you did not ask me, why doesn't this mass appear? So we can discuss this next time. We will see next time why didn't we include this mass. So this is in this side, this angle is 90 degree. This is our V2. Okay, everyone, thank you. Next time I can talk about why didn't we consider this mass.
Thank you, Hocam.
Thank you, bye-bye. Okay, any questions from anyone? Should I? Hocam, what is V? V2? Okay, where is V? Where did I write V? This is V2. Yeah, so we have to find the V2, right? The final velocity. So where did I write V, Kevin? Yeah, so you can write integral 0 to t here, and you can use the velocity, but I'm using, you can use the symbol V, but I'm using V2. So T1 to T2 and V1 to V2. Thank you. Bye bye. Where is? Okay, chat message. How did you get V2? Oh, how did I get V2? So I said this is equal to H2 minus H1, change of momentum. And I said that V2 is equal to R omega. And I suppose I multiplied 400 millimeter, that is 0.4 with 15.7. Agreed? Yes or no? Yes. So V2, I suppose I multiply, look, V2, can you, yes, okay. Any further questions for me, Kevin? If you're still writing, I can wait, or should I close the session? Because now I have a couple of students who are waiting for me, I think. You can take a picture, no? Okay, we have a chat message from Kevin. Done? Okay. I will remove this picture as well so that there are. Okay. Okay, Kevin. Thank you. Bye bye. Bye bye, Kevin.